control output. So this is the control system block diagram given. We need to find out the transfer function. So C of S by R of S. Generally, when they given in terms of block diagram to find out the transfer function, so we need to reduce all the blocks into a single block in between input and output. That block gain will gives you the transfer function of the total block diagram. So that means we need to reduce all these blocks into single blocks, single block. That block gain will represent the overall gain or transfer function of this control system block diagram. So now here we are having so many ways. According to our reduction rules, we can apply any of the rule, at any place we can apply any rule. So for example, you can see, you can move this point to here to release these blocks, or you can move this point to here to reduce this feedback loop. So which you want, you can do. So I want to move my point to here to here. I want to move my branch point or this point to here. So that means you just treat these are 2 points. So one is for feedback, another one is for H1. So I'm just making this line as it is, but whatever connection to this is there, that I want to move here. I don't want to move this feedback. I just want to move this point to here. That's it. So now you can see how my block diagram is going to change. So now I'm having another summing. See, if you want to move this point to here, what we need to do? So we need to add an extra block. So this G4. Need this here, you can see to here. So G4 to both lines connected to this point. So for this H1 into G4, for this here I'm not having any block. That means you just treat that line gain as 1 into G4, G4. So like this. So this H2 is from here. So now you can see your feedback path is free now. So this feedback path you can reduce to negative feedback gain. So that means G3 divided by 1 plus G3 H1 G4. So I'm reducing this block diagram like this. So here I'm having a summing point, and here I'm having G1, and taking this G4 little bit up, I can write this is G2. Reduce this with feedback gain. Feedback G by as G3 into H1 G4. So you are having both, and here also we are having, this is arcs are in series. When you are adding negative feedback gain, so that means you can make that total feedback path as feedback path gain. So now, and so this feedback loop, that means with negative feedback, I can write this as, so G2 G3 divided by 1 plus H2 into G2 G3 divided by 1 plus G3 G4 H1. Now you can see, so in place of this feedback, I written like this. You just treat like this G open is equivalent to open loop gain divided by 1 plus open loop gain into feedback gain. So G by 1 plus GH, G divided by 1 plus G into H. So that form I written there. So now, so if you reduce this, what you are going to get? So G H1 G4 divided by G2 G3. So now, so I reduced this feedback path. I reduced this feedback path and I'm having this G4 and then this feedback. So my reduced block diagram up to now. So you can see these two blocks are in series, G2, G. Again, we can apply formula G by 1 plus GH divided G by 2 to get, so G1, G2, G3 divided by, so by cross multiplying, you are going to get, you can see, just cross multiply and cancel the denominator. I reduced this feedback path and I'm having this G4 and then this feedback. So I'm having this G4, I'm having this G4 and the C of S, and here I'm having feedback, another feedback G4. So like this I'm having, this is my reduced block diagram up to now. So you can see these two blocks are in series. Definitely we can take out this block and we can make this a single block by multiplying G1, G2, G3. And here this block is in feedback. So that is also negative feedback. Again, we can apply formula G by 1 plus GH. You just treat this as H and you just treat this as G. So I'm writing that. So that gain is equivalent to, first of all, I'm solving the gain here, G by, that means G1, G2, G3 divided by 1 plus G3, G4, H1 plus G2, G3, H2 divided by, so G by 1 plus GH. So this G again we need to write G1, G2, G3 divided by 1 plus G3, G4. H, you are going to read G2 as you see of this block 2 plus G4. So this